problem right here. I have acetic acid and I need to make an ester out of it, and I want to know a good reaction. There are two possibilities. What is the first reaction you learn to convert a carboxylic acid to an ester? It was, hopefully you're thinking about the Fischer esterification. And if you use the Fischer esterification, you're going to take your acetic acid. We need this alcohol right here. So 1, 2, 3, we need propanol. So we're going to add propanol. And the other thing that we need that's very important for the Fischer esterification is catalytic amount of acid. So we knew when we actually studied the Fischer esterification, we learned that it's going to be an equilibrium reaction, that it's not going to ever give you 100% because, again, it's an equilibrium going back and forth. So in that case, you use a large excess of the alcohol. When I put XS, I mean the excess. There's a much better reaction to make an ester from this carboxylic acid, and it's starting from the most reactive carbonyl that we have. All right, so I know that the carboxylic acid is not that reactive, but I can take that acetic acid, replace the OH for a chloride. Do you remember the reagent that you need to replace the OH for the chloride? You do? Thionyl chloride. I like thionyl chloride. If you don't want to use thionyl chloride, you can use phosphorus pentoxide. But in one step, you get the most reactive carbonyl. And now it's a matter of adding propanol, but I don't have to use an excess anymore. Because this is the most reactive carbonyl, I only need just the right amount. I don't need the blue one. The right amount of propanol to get this reaction going. And I get a much higher yield of the ester. So I know the Fischer reaction is a way to go in one step, but the second part right here is a much better way to actually completing the synthesis in a much higher yield. Saponification. Saponification is a good reaction, and it's the basic hydrolysis of an ester. And when I say base, I mean that you have to use either sodium hydroxide or potassium hydroxide. All right, so saponification, it's a word that means that we're making soap out of it. And we are going to use a fatty acid. So I'm going to use for this one that has 16 carbons. It has to be an ester because it has to be the basic hydrolysis of an ester. So this right here has 15, 16 carbons right here. We're going to take sodium hydroxide, a solution of sodium hydroxide in water, and we're going to boil it or reflux it for a little while. What we're going to do is that we're going to break this bond right here. That's what we're going to notice. So this side would give us the carboxylic acid, but we won't be going straight to the carboxylic acid because we're under really strong basic conditions. So we don't get the carboxylic acid, we get the carboxylate. And this side, if you're worried about this side is just going to form the alcohol. So this one right here, I need a counter ion. What's the counter ion that goes right here? Sodium. Very good. So sodium. This is sodium palmitate. And this is perhaps one of the, what should I call them, classier soaps, because this is from palm oil. if you were one of the pioneers going to the west, you would take beef tallow and do the exact same reaction. So beef tallow would actually render you octadecanoic acid, or this is also called stearic acid. So if you actually read, let's see, the back of your soap box, or maybe of the detergent that we use to wash dishes, check if you have stearic acid or if you have palmitate. So this is the saponification reaction, and again, it has to be, must be, under basic conditions for us to use the word saponification. Esters, we have seen this before. Esters can be reduced to the primary alcohol with lithium aluminum hydride. If you use one of the cousins of lithium aluminum hydride, like dival, we have used dival before, we're going to get an aldehyde out of it. Now, just as a reminder, dival stands for diisobutyl aluminum hydride. So diisobutyl aluminum hydride, it has only one hydride, so that's why it gets you the aldehyde. One more slide for this part. All right, different question. I have an ester and I want to make it into an alcohol. Could you please classify the alcohol for me? Is it primary, secondary, or tertiary? Is that enough time? It's a tertiary alcohol. And if you notice, I had a phenyl to begin with, and we added 2 more phenols. Whenever you actually add 2 groups are the same and you get an alcohol, that's because we're adding a Grignard to the ester. So I need the Grignard that has the phenyl rings. So phenyl magnesium, bromide or chloride. I know automatically that 2 of these Grignards will attack the ester. Remember, 2 of them will attack, so why not actually use enough of it to get a really good yield of our tertiary alcohol? All right, this concludes the first part of the carboxylic acid derivatives. I hope you come and listen in to the second part.